How's it going, everybody? So today we're going to be talking about real world problems and kind of how we handle situations where we involve maybe a little bit of physics. So for these nonlinear systems right here, what you're reading about is a person is kicking a soccer ball, okay? And the idea is that it's interacting with this hill. And so this person starts at the base of the hill, kicks towards it, and where does it land on the hill? So let's go ahead and read the full problem. It says the graph shows the height, y in feet, of a soccer ball x seconds after it is kicked from the base of a hill with an initial velocity of 30 feet per second. The linear function represents a hill with a constant slope. After how many seconds does the soccer ball land on the hill? Check the reasonableness of the solution or solutions. So the first thing you have to understand about these real world problems is an equation that is pretty consistent in physics, which is the y equals negative 16x squared plus v sub o x plus h sub o. Now, I've also heard people call it v initial and h initial. And the idea is these components describe various things that are happening in the graph. So first and foremost, let's talk about this negative 16. This negative 16 is actually the acceleration due to gravity. So this right here is a constant because gravity is constantly pulling on you, okay? And that's why this number is automatically given in the formula, because gravity is never changing. If it ever changed, you would know, right? Now, the initial velocity is something that is left open, as well as the initial height, because we don't quite know what the velocity is. It depends upon the problem. And we don't know the height at which the object starts until we are told at which height it starts at. So these components you have to find out within the problem itself. Now, looking at this problem right here, you are given the initial velocity. It says it right here, the initial velocity is 30 feet per second. Now, the units themselves are always important, but in terms of solving, not as much. But definitely always make sure you know units are important, because without units, math would be pointless, right? Now it says, the next part we have the height. The height says that it's at the base of the hill, okay? Now you gotta understand what the base of a hill means. That means you're at the bottom, okay? Where you have zero height, okay? Your height is zero. So we understand that our, our v sub o is equal to 30. And then our height, our h sub o, is equal to 0. You could also see this kind of information given to you on the graph over here. You'll notice this is u right here starting at h sub 0, which is the height. Now, the graph itself, as you move along it, is moving at the v sub o, okay, of 30, okay, with, of course, it going down, because as something goes up into the air, it has to come back down due to gravity, which is why gravity is a negative number, because gravity's pulling you down, and the direction down is what makes that number negative. The reason why 30 is positive is because you kick it upward at that 30 miles per hour, right? Or that 30 feet per second, I should say. And so that's why it's positive. So with that being said, this right here would create our first equation in our nonlinear system of y is equal to negative 16x squared plus 30x plus 0. Is the 0 necessary? I would say no. You don't need the 0, but if you need it for the formula, definitely put it in there. Now, you were also told that the hill is growing at a constant slope, okay? And you could actually do the, point slope form, and you could figure out that this right here is a linear line. But you could also look at it too, that it grows at a constant rate. And so if you did your y equals your mx plus b, well, first off, the y-intercept is at 0, 0. So you have y equals mx plus 0. And it's at a constant slope where if you did, just up, rise over run, you'd go up 1, over 1, up 1, over 1. And so if you have a slope, an m, of 1 over 1, that's just m is equal to 1. So you would just end up with y is equal to a 1x plus 0. But once again, not needed for some of that. You could just write it as y equals x. So this is the next equation. Now, we're fully set up to go ahead and solve, and you have the ability to use elimination or substitution, right? Both are at your disposal. I recommend substitution is the easiest avenue because they're already solved for y. So why not? So let's go ahead and use substitution. I'm going to go ahead and plug this right here into this y value here. And this is going to give me I'll use a separate color, x is equal to a negative 16x squared plus 30x. Now we need to combine like terms and then solve for the value of x to figure out the intersection. Now guys, you can see the intersections on the graph, and if you wanted to make guesstimates, you probably could. But right there is an intersection, and over here is an intersection. So honestly, just looking at this right here, I could make, a reasonable guess that, okay, this first intersection right here, I'm pretty sure that I should get it at 0, 0. Like, that looks just like it's at 0, 0, which makes sense because the ball and the base of the hill start at the same spot. So 0, 0 does make sense for the first intersection. Now, this next one right here, I see that the x value is a little bit past 1.5. So I would say that this is at maybe x is equal to 1.7 or maybe 1.8. Okay, now how close, I'm not sure, but it should be around there because it's a little bit past 1.5. So let's figure out what the actual number is. So to do that, we're going to subtract x on both sides. And you have 0 is equal to negative 16x squared plus 29x, okay? Now, at this point in time, you have the ability to go ahead and solve utilizing that special case within that AC method. You'll notice your C value is non-existent. So you could factor out an x. Oh, I switched colors on you. You could factor out an x, and it would look like this. You would have x and then negative 16x plus 29. Now, 16 and 29, I don't believe they have anything in common, so we'll leave them alone. But we could start solving for the values of where x is going to be at the intersection. So for the first one, we're at x is equal to 0. And then we're also at negative 16x plus 29 is equal to 0, okay? And so this first one is already solved for you because there's really no need to go any further than that. But this next one needs some doctoring up. So we have negative 16x is equal to negative 29. We're going to divide by negative 16 on either side. And so that's going to give you x is equal to, and I believe, let me see here. Let me do that in the calculator. And that got me 1.8125. So this right here, ladies and gentlemen, is telling me this would be the direction, or not the direction, but the location of the other intersection. And remember, in this over here, it says that the x is time, right? And you got to look at the graph to understand that the x is time, okay? This is all time. Over here, this is height, okay? So just be aware of what the graph's communicating. So for my second intersection, we actually found the answer already because it says, after how many seconds does the soccer ball land on the hill? Well, the soccer ball would do it in 1.8125 seconds. And so this right here is your official answer. This is not because this is where the ball started. That was the starting point, okay? This is where it started. This is where it finished, okay? And it hit the hill. And so that's the big idea, guys, is you're going to have to be able to utilize that equation, especially on your upcoming exam, to kind of describe some of these physics problems that happen in some of these nonlinear systems, okay? Alrighty, guys, so that's it for the real world problems. Let me know if you have any questions and any concerns. Thank you, guys.